Hi all, and welcome to the physics design environment demo. The purpose of this demo is to show the usefulness of the design environment, for which we'll start the process from the Docker compose file, design a hello world function in the design environment, build a simple function from it, and test it on the test OpenWhisk platform for the first step. So let's start with the design environment. We use the sudo docker compose app in order to launch the containers that include the design environment. The design environment collaborates with an online repository from which we have added the files. We have copied the initial files of physics, and then in our own branch we can do differentiations in terms of the Docker file we are using, if we want to start from our own version or if we want to keep the default one that is offered by the physics environment. Now that the environment has started, we go into the main panel. We can see the Node-RED server and in the admin panel also with the various cases. I have configured the design environment to have the branch name George, and I can look at logs from the executions here from all involved services. Let's go and start designing a flow. You can see here the palette that is enriched with some of the physics additions in terms of the helper flows, in terms of the patterns, and in terms of the annotators. So let's start creating a new flow. Let's initially consult the OpenWhisk skeleton that gives us the primary interface of OpenWhisk. So there are two methods, a post init and a post run, that is required, and the fact that we need a JSON response and some arguments info that tell us a small differentiation with relation to how arguments are passed. So if we can copy, for example, this case, put them in our flow, we will name demo, and we can copy them directly here. So here we have a function where we can add something. So in our specific case, we just take a parameter that is the value name, and then we put it as a member. But in this case, we need to remember that we need a JSON response, so we need to have a kind of JSON structure that includes also the name that we get. We can also add annotations with relations to how we want this to be executed. So we want it to be executed as a node function, not as a service or as a native sequence. And let's say that we want, for example, to configure it to be to have 256 megabytes and a timeout of 300 seconds. We can add also other annotators here with relation to optimization goal, any DMS interface to the data management service, affinity, and so on. So let's push deploy. This is helpful to store the flows locally. And then we can go to the admin panel and see that we have a new flow created. Now this flow has not been built yet, meaning that we do not have a deployable image based on which we can register it to a fast platform like OpenWhisk. So we are going to push build in order for this process to kick out. So in a while we will see the Jenkins link. Okay, you can see that the Jenkins build has started, and we can go and observe what is going on. So the Jenkins gets triggered, and then a specific pipeline is launched in order to produce the reusable Docker image. So in that process, the design environment pushes the differences to the repository. From my branch, it will copy the flows inside the min.io object storage, and then it will be based in an initial baseline image, which it will change in order to include the new flows. This process takes a while, and after that we have another build layer in order to include also other dependencies that we have added in the design environment. So if, for example, I add here in the panel another node, another library, if I go, for example, here and add a new node, and I install another node from the, let's say, physics from the Node-RED repository, this will be included in my palette, and it will also be copied in the image that I create here. This process takes a while, so we can go and see the overview. So you see that the pipeline has a number of stages. We are now in the almost final stage. Okay, we are done. You see that after this pipeline, we have another pipeline that has the goal of registering a test function to a test OpenWhisk platform. Okay, this is very fast, has just finished. And what this does is basically takes the image we have created before. So let's see the image that we have created. Okay, this is the image that we just created from the first pipeline, and then we go and register it to OpenWhisk in order to be able to be invocable. So now we can, for example, copy that name, or we don't even need to copy that, it will be automatically added. You can see here that the hello demo has been built. What is the image, what is the action name, and the build date, and we can go and test. So here my branch has the latest build images, so I can use this one and then require. and I can invoke it. Now we are waiting for the invocation to finish. Okay, so you can see that we just received a reply. So if we want now to see the second part of the demo, the second part is about using one of the patterns that we have brought in physics, the split join multiple pattern. So in that case, we have already prepared the flow. This split join multiple, you can feed it with an array of inputs. You can feed it with an array of inputs. You can configure it via UI or via the message that comes in. And what this does is that you can set a split size. In our case, we will be using 2, which means that we will be splitting the execution of these 4 inputs, these hello world inputs, to be done across 2 functions, 2 hello world functions. Each of these hello world functions will undertake 2 out of 4 initial execution. At the same time, we will show the backend of the OpenShift cluster in order to show the function execution. So let's proceed with the flows. We have already built this flow. So we have the templates. We have configured this with the split size. The execution here is fast. We have other versions like local multithread or local multiprocess. We'll be using fast. The interaction URL will be included in the arguments of the call. And we define also the OpenWhisk endpoint and the namespace. The credentials are also fed in during the input call. We can also test locally. So we can test here in order to save time from building that image. This means that the orchestration in this case will be done from inside our Node-RED server, and it will just invoke the 2 external actions. But for our primary execution step, we will be using this one. This one we will be calling the function that we have built, so that we can see 3 functions. One is the orchestrating function. So this part here will be also executed as a function, and it will invoke the other 2 functions, wait until they finish, join the result, and give us the complete answer. So in that case, we have already built it to save some time. You can see here, multiple, it's already built. And we can go and push the test button. Mention that for this specific variation, we're using a different hello world function that is able also to process arrays of inputs. Okay, that's the main differentiation with the initial hello world function we created. This part that is able also to check if the input is an array, and then let's say implement the hello world for all the elements in the array. If it's not an array, it goes with the typical let's see case.